Good to have you back. All right, acceleration. So that's the lesson for today. What it really means, and then we're going to go through a few examples. A quick review is that there are 5 core variables when we talk about kinematics and in kinematics chapter. Remember the study of motion, and the 5 I listed them here just in case you've forgotten them: time, displacement, initial velocity, final velocity, and then of course acceleration. Now of course distance is there, but distance, remember, is a scalar, displacement is vector, and so as a speed, but I didn't put that in there because it's already implied. All right, so today we're going to talk about acceleration. So basically acceleration, by definition, you already know what it is. It's the rate of change of velocity. That means how fast your speed changes. That's what it means, the rate of change of velocity of a given object, and is given by this acceleration velocity divided by time. This is change in velocity divided by change in time. Now as you go through the higher level physics course, you notice that sometimes they put a little arrow on top of acceleration, or even velocity, they do that. Anything that is vector, they put an arrow on top. Okay, now I do need to rewrite this equation and explain what delta V is. Delta V is basically the change, the V final minus V initial divided by T final minus T initial, or T2 minus T1. That's what delta, change in velocity, delta, and delta t, change in time. Okay, so that's that formula, and we're going to use that often. Now we're going to talk about, I put down few notes here for learning goals. Distinguish between positive and negative acceleration. Because acceleration is a vector, therefore direction matters. Simple as that. Okay, simple as that. Now sometimes it does mean, the negative acceleration does mean sometimes is a slowing down, but not all the time, because it could be that you're starting your direction to a negative direction from the reference point of origin, and that's okay. All right, and that would be a negative acceleration. So imagine you are driving your car, but you're putting in a reverse gear, and you pressing the gas pedal, and you're going backwards at the high speed and high acceleration. Well, you're going negatively. Let's suppose you're coming out of a certain place, and that's a negative acceleration. That doesn't mean that you're slowing down. It could mean, as you're going ahead, you're speeding up, you see a police on the highway with the radar, and what do? You slam on a brake, and sure enough, you're slowing down. Yes, that is a negative acceleration as well. So it's not automatically implied. And the last thing is that we're going to talk about interpreting acceleration from velocity time graph, but this one I'm going to use a separate lesson for this, because this one is actually a little bit more involved than just talking about it with a few examples. This is, we're going to take the entire 10 minutes to talk about this. All right, let's go through a couple of examples, but I did put in here again the formula. I should put in here V final minus V initial divided by T final minus T initial. That's the velocity. And then, but remember, the unit is always meters per second squared, but always the time is being squared. Okay, so it could be that it's kilometers per hour squared. These are all different units that could play, but usually the most famous one is meters per second squared. And remember, acceleration is a vector. We already talked about that. It needs needs magnitude and direction. And then the last piece is that we have constant acceleration and non-constant acceleration. They call them uniform acceleration in some cases, and most cases. The uniform acceleration means that it is accelerating uniformly. It's not going up and down. It's constant acceleration. And the non-constant acceleration is that it changes, of course. All right, that's what that is. All right, let's look at a couple of examples. The first one, very easy. Car slowing down while moving forward. Very good. So original, you're moving at 20 meters per second, then you slow down at 10 meters per second and the time that it takes is 5. So let's write up the acceleration formula, but here it is. So you have the final is 10 meters per second. The initial is 20 meters per second. I'm going to subtract that, and then the total time is 5 seconds because t initial is 0. That's what we're assuming. T initial is 0 second, so that would be 5 second. And now when you do the math on that one, you'll end up getting minus 10 meters per second divided by 5 second, and that is -2 meters per second squared, which is right there. Okay, simple as that. All right, let's look at another example. One note I put in there for me so that I don't forget: negative acceleration will still moving forward. This is very important. I've got few students throughout the years that they always make a mistake, that they think that once you have a negative acceleration, you need to be not moving. That's not true. Okay, you can slow down and you are having a negative acceleration. I just showed you here, and that's an example. All right, let's look at another question. Now, car speeding up backwards. This is a very good one. I did the example with my students as well. So here we want to know how the acceleration works, but notice that, so you're going backwards. So the acceleration, I'm going to write it up here. So we have minus 15 meters per second minus 5 meters per second. Ooh, this is going to be tricky. You got to be careful with that, because remember, what is your v initial? Negative 5 meters per second. What is your v final? Negative 15 meters per second. Okay, so if we have that, and the time, by the way, delta t is 2 seconds when there is a differential between the velocity happens. Okay, so now v final minus v initial. Notice that I have a minus in here. That's part of the formula. Okay, and then of course negative in here. That negative is part of that. That's not different. Okay, now we're going to go ahead and divide by 2 seconds. And when you do this, this is the plus sign. So negative 15 plus 5, that's meters per second, meters per second. You have to include the units. Don't forget the units. And now you get negative 5 meters per second squared. Okay, so here it is. So yes, you are still having a negative acceleration, but you are speeding up. Okay, that's what is happening. So you are speeding up. Here it is. All right. So another question, number 3, the free fall. This acceleration due to gravity, and that's just the general thing, and it's measured at negative 9.8 meters per second squared, given the ignoring the air resistance. Okay, and what that means is this: for every second, so let's suppose you have this rock that you are dropping down, and there is a distance, the height h, and this is being dropped down, this rock being dropped down from there. The moment you let go of that rock, this rock will pick up a speed at the rate of 9.8 meters per second per second. That means it becomes faster and faster every second by 9.8 meters per second. Now rewind that and re-listen to what I just mentioned, okay? So for every second, so the first second when it drops from the height, the first second, second one, your speed at second one, you clock it, is 9.8 meters per second. But at second, so at time t equal to 2 seconds, your speed is now 9.8 meters per second, and then add another 9.8 meters per second. That's 19 0.6 meters per second. So that's what this acceleration due to gravity is, and this negative in front is just telling you that it's coming towards Earth. That's what that is. It's pulling it down. So velocity becomes more negative each second. Of course it is, because this becomes, there's a negative there, there's a negative there, and there's a negative there. Okay, so that's what it means. Now, the final velocity just before hitting the ground, well, every time, depending on how far, how high is that rock being dropped at. Remember that the free fall, the acceleration due to gravity, is negative 9.8 meters per second, but negative means it's coming towards Earth. Okay, and if it's going up, it's positive 9.8. All right, so that's what that is. All right, I think that's it for now. Check out the next video in the series. We're going to continue with these questions on acceleration and uniform acceleration. All right, don't forget to take the quiz that I post, that I include with every video. Check out the pinned comment or in the description below, right at the beginning. But make sure that when you are taking the quiz, either you're taking it as a review. I suggest you take it as a quiz. All right. So do a few questions yourself. Make sure you know how to do them. And then you take the quiz to test yourself. And then you go back and check your answers and then see where you went wrong and then learn from that. All right. Until next time.